Hello, my name is Mronal, and in this presentation, I'll be talking about LiDAR and its applications. The definition of LiDAR stands as light detection and ranging. It's a remote sensing technology that uses laser pulses to map Earth's surface in 3D. LiDAR works on a principle like it contains a pulsar that emits laser pulses in a really fast manner. And when the laser pulses hit the object reflects back some laser pulses and it comes back to the photodetector. Photodetector detects the light and the time of flight is calculated. And because of this, we can calculate the distance between the object and the laser pulse, uh, object and the detector. History of LiDAR goes as if it was first used for aerospace and defense applications, then in industries, and then for exploration and automotive applications. And now, finally, we are using it in automated cars and autonomous vehicles and other broader applications. So, how LiDAR works? As I said before, LiDAR contains a laser source, detector, and and I have already explained the process. It consists of emitting laser pulses, receiving reflected signals, calculate distance based on time of flight, and output we get is 3D point cloud and elevation maps. In this photo, we can see there is a bridge in the canyon, and as you can see in the photo on the left side, we can see there's a light. We can see different colors of different light point clouds. This is the output of LiDAR from the front, and the one above it uh, is from the up upside of the uh, bridge. How the point cloud is looking from the upside, and if this one is from the front. This is a simplified diagram of how the LiDAR works. As I said, laser source and light laser pulse in T1 and the laser sensor receives in T2. There are different types of LiDAR: aerial one, terrestrial one, mobile one, and bathymetric one. Aerial one is used by drone and helicopter or something like that to measure terrain. Terrestrial one is kept on the ground and measured the point cloud is obtained. And the mobile one is one that is mounted on the car and measured accordingly. And bathymetric LiDAR is the one which works underwater. Data analysis process, data collection. LiDAR takes the raw data from the LiDAR and uses it to processes the data to make the point model. And with the point-to-point model, we can make digital elevation models and digital surface model. Elevation models creating representation of terrain, showing height and changes across the surface. Key techniques in LiDAR analysis. Point cloud processing. As I said before, we make a point cloud out of the data we get. Voxel-based filtering, and in the voxel-based filtering, we reduce the noise and aggregate the data accordingly. And in machine learning and AI applications, we can distinguish the point cloud as a tree, as a building, and something like that. Like as we can see in the diagram below it, we can see on the raw data, it makes some usable data. Analytical models using LiDAR data. We can use a topography analysis from the terrain, mountains, rivers, and other things. Environmental analysis, as we can see, we can do forest canopy analysis with the help of this one, and this structural analysis, which we can use to do the structural analysis of buildings and towers and all that. Applications of LiDAR. Environmental monitoring, as I said before, we can see coastal erosion studies with the help of LiDAR, as we can see in the photo here, which shows a on the right side which shows island, which is a island or peninsula type of thing, and then there's the erosion occurs in it and the water passes through, erodes the land and passes through it. Autonomous vehicles use LiDAR to measure the distance of the things around it and move accordingly. Urban planning, it can be used for urban planning. We can see how much land we have, how much how many buildings and how tall of building we can make. And it can also be used in disaster management when there's a flood or something like that. When we can't see the things but the LiDAR can, and we can save lives on this. Advantages of LiDAR: it is high accuracy and resolution, provide detailed precision measurements of distance and elevation, producing high resolution spatial models. Versatile applications, and speed of collection is very high, and it can penetrate vegetation. Like forest leaves, and lot more things. It can penetrate those. That's why it helps. Challenges in LiDAR analysis are that it is a high cost thing technique. The equipment costs too much, and the lasers and detectors they cost too much. And volume data is very large to process. And there could be atmospheric interference like a rain, fog, dust, and it will introduce noise in the point cloud. And one major challenge in data analysis is that it performs poorly when we pass it through the transparent surface. It will just pass the transparent surface without giving a proper point cloud. Case studies and real life examples. One case study is forest management conservation, monitoring forest canopy in the Amazon, track deforestation, biomass, biodiversity loss over time. Method: LiDAR collects data and suggests the we can suggest the solution to the problem after seeing this. Case study 2 is about urban planning and infrastructure monitoring. We can plan urban areas with the help of LiDAR. If we use manpower to this, it will take too much amount of time. But if we measure it with the LiDAR, it will be really get very easy and very effective and sustainable. Future trends in LiDAR data analysis, real-time data processing, integration with other remote sensing techniques like synthetic aperture radar, hyperspectral imaging, and thermal imaging or richer database. For example, LiDAR plus SAR for vegetation analysis, where SAR data aids in detection of moisture content, and LiDAR in structure. Cloud-based processing storage rapidly convert data over large areas, ideal for quick assessment and large-scale projects. Miniature and cost reduction can measure surface even beneath forest canopies, unlike object optical imaging, which is blocked by leaves and branches. So, in summary, uh, what LiDAR is a versatile technology. The analytical power of LiDAR is beyond imagination. Future growth with help of AI is really is what we are looking forward to, and LiDAR will definitely help in addressing global challenges.